Hello everyone, welcome back to the series. This is episode 9 of building a chat app in C from scratch. In the last episode, we made it so that we could finally send a message within our chat application, so we can reply to our message like, how are you? The other person can reply and say, I'm doing great. Today, we're gonna be making our chat application receive full messages reliably. So without further ado, let's jump right in. Alright guys, so let's get started. So let's review our receive message function within our chat application. Oh, by the way guys, I just realized I made a mistake in the last episode where I did a calloc 1024 0 right here, but like it should just be a size of a char instead. That was what was causing the crashes within our program and stuff, So, as I was saying, our current way that we're receiving our message is just receiving it within a limited buffer size of 1024 bytes. Now here is the issue with that. Let's say we sent 5000 bytes or 5000 characters of a message, then we would not get that. And also if we send a message of length 5, our receive function will not wait on us to receive this 1024 bytes even though we tell it should receive it. Right? So chatsock receive doesn't receive the number of bytes exactly that we specify. So we're gonna start by creating a new function that will allow us to receive all of our bytes. So let's start doing that. So let's open up our chatsock.h and our chatsock.c. So let's create a prototype. Let's make it a int chatsock receive all, and it will accept a chatsock t chatsock void pointer buffer and then our buffer size. And now let's copy this prototype and let's start implementing it. So we go to our chatsock.c, let's paste this in there. So in order to receive our full message, let's define a size t total bytes received right here. We'll set it equal to 0. And we'll say while our total number of bytes received is less than the maximum size that we should receive, or the maximum number of size, which is our buff size. Then we'll say int result is equal to chatsock receive. Then we'll pass in our chat socket, then our buffer, then our buffer size. Now here's the thing guys, with receive returns a value less than or equal to 0 whenever an error occurs. Specifically, it returns 0 when a client disconnects. But we're not gonna be handling disconnections in this video, in this episode. Instead, we'll just do something like this. We'll say if our result is less than or equal to 0, meaning it failed, or receive failed, we will just return our result. Otherwise, we'll just get our result. Also guys, receive returns the number of bytes that we received right? So we'll just take our number of bytes that we received, and we'll add it to our total bytes received. So we'll say total bytes received plus equal to our result. Then we will just return our total bytes received right here. So that is our receive all function. So let's start allowing implementing our flexible or reliable receive within our chat server. So currently we have a broadcast thread, we have a receive message thread, and we also have in our main thread a accept thread. Now all of these things, guys, we're gonna need to move them to a separate thread, like this accept thing and all of that. So let's start doing that. So we're gonna move them to our socket library. We're gonna do a abstraction on each one of these things and add it to our actual chat socket library. So let's start by opening up our chatsockdef.h, and let's start by opening our chatsock_list.h and our chatsock_list.c. Now in our chatsockdef.h, currently our chatsock list, guys, it when its item type or the data it stores is of the type chatsock_t. We're gonna define a new type so that we can have some new, like, multiple data types within our socket list item. Right, so we'll do a type def struct chatsock item. We'll then say chatsock item t. Well, then it will contain a chatsock t sock, and it will contain a pthread t receive thread. Because currently, guys, our server, right, it has a receive thread that gets started. Hold on, where it is? Yeah, so after we accept a connection, we essentially add it to our client list, which is right here. Then we start a receive thread. So because we're gonna be adding abstraction, we'll need to add that as a new member of our chat socket item. We'll also have a bool receive started flug for whenever we actually start our receive thread, and we'll have a bool receive finished flug for when we fully receive a message. Okay. So now, guys, we'll need to replace our chatsock t pointer list with a chatsock item t. So now we can go back to our chatsock list.c, and right here where we're allocating our memory, we'll need to change the type to a chatsock item t, and also the size of times the size of a chatsock t, we'll change that to the size of a chatsock item t. So our close function, it accepts a chatsock t, chatsock, but this type is a chatsock item t, so we'll have to do a .sock right here. Oh, and we can't forget to, because we'll need to set our item socket, right? So therefore we'll go right here and we'll do a .sock is equal to sock right there. and then we'll set it equal to our actual socket. Now guys, this receive started and receive finished and all of these stuff, we need to null terminate them. So before we initialize our new item that we're adding to our list, we'll just do a memset new sockets, and we'll add the old offset, which is our sockets count, to our new sockets pointer, so it gets null terminates the appropriate item within our list, and then we'll pass in 0, and then we'll pass in the size of the chatsock item t right there. And yeah, that should be it, guys. So now, once we do that, each one of these flags are gonna be set to false automatically. So now, let's start working on our accept thread, because currently it's inside of this loop, of our main thread, but we're gonna move accept to its own thread. So let's start by creating a prototype. So we go in our chatsock.list.c. We're gonna add some new functions. We're gonna add a void chatsock list accept. Well, let's make it a void pointer, which will essentially, and it will accept a void pointer arg. So this will essentially be our function pointer that will pass in when we're creating our thread. And we'll have a, let's see, pthread t chatsock list start accept start underscore accept. Let's define a new type within our chatsock def.h. So it will be a type def struct chatsock, let's call it accept arg, which will be the argument that we will pass in as a pointer to our start accept function, which will essentially start a thread that we will accept our connection. And then it will add it to our list. So this structure will contain a, let's see, a chatsock list t pointer client list, and it will contain a chatsock t, which will be our actual server socket, and the type of it will be a chatsock accept arg underscore t. Yeah, and then that is it. Oh, and the reason why we have this error right here is because we need to include pthread.h, and we also need to include std bool.h. Right, so now that we have done that, we can now have access to our pthreads. Right, so let's say we start our accept now. So our accept will accept a chatsock list t pointer to some sockets. It will also accept a chatsock t to our particular socket, which is gonna be our server socket. Then we'll have a void chatsock list join accept, which will just take in our accept thread. So exception thread, and it will just wait for it to join. And yeah, so let's start implementing these functions now. So let's go to our chatsock list.c, and we're just gonna paste this in. So let's implement our void pointer function. Okay, so our chatsock list accept function. So let's just copy from outside of this loop, and can just delete that and we'll paste it into our chat sock list accept thing. We will wrap this in a infinite loop, so we'll do a while one right here. We'll indent all of these. So we'll need to, we'll need to add our connection to a client list. So we'll have a chat sock list t pointer client list, and it will cast it to a chat sock list, to a chat sock list t pointer arg. We'll then get our actual server socket, so we'll say chat sock t sock is equal to, wait, hold on. Our argument will be of the type or start accept. Yeah, it will be of the type chat sock accept arg underscore t pointer exception arg. So therefore, we'll need to have a chat sock accept arg t pointer exception arg is equal to chat sock accept arg t pointer arg. Then we can get our client list now. So we can say exception arg client list. Then we can say, we can get our actual server socket. So we'll say sock is equal to our exception arg sock per socket, and that will be it. Now we'll need to add our connected client to our client list. So we'll do chat sock list add socket client list. So let's do that. Okay. Yeah, and that is it, guys. So now that we have done that, we'll need to let's add a to do here. We'll say start a receive thread after accepting a client, because in our server we start a thread immediately after accepting a client. Okay, so let's work on the start accept function. Let's copy this prototype, this new prototype here, and we'll replace it with this. So now let's start creating this function. So our start accept function, it will essentially create a new thread. So we'll do a pthread create &new thread. Then we'll pass in our attributes will be null. Then we'll pass in a pointer to our chat sock list accept function. Then our argument will be our exception argument. and then our join accept function will just do a pthread join exception thread, and then null, because we don't want any return value. But we need to also remember to return our new thread right here. Now that we have done that, guys, we can start working on our, let's see, yeah, we can start working on our receive thread, because currently each client has their own thread, or their own receive thread, right? We have receive start and we have receive finished. So we'll start implementing our receive message thing. So let's do that. So let's define some prototypes for our receive. So we'll have a void pointer checksock list receive underscore message void pointer arg. This should be checksock right there. Okay. So then we'll have a void checksock list underscore start receive. So we'll say, so it will accept a checksock list t pointer sockets, and it will accept a index of that particular socket, so it will be a size t index. Then we'll have another one which will allow us to retrieve our message from our thread. So we'll make it be a char pointer checksock list join receive checksock list t socket size t index, and let's copy all of these prototypes and then implement them. So let's start implementing our receive function. So we'll need to, let's see, so we start our receive thread right down here. We need to pass in some arguments like our current client and our client list. So since we need to do that, let's define a receive argument structure. So we'll do a type def struct checksock receive arg, and we'll say checksock receive arg underscore t. We'll then say we'll get a checksock list t pointer client list. We'll then have a size t client index, which will be the client that we'll receive from. And then let's implement our receive message function. So now we can just say checksock receive arg t pointer receive arg is equal to checksock receive arg t pointer arg. Then we can get to our client list, so we can say checksock list t pointer client list is equal to receive arg client list. Then we can say client list count, client list count. Oh, we don't need no count, right? It should just be, our client index, right? So we'll need to get our actual socket. So therefore, we'll say chatsock underscore t. Let's call it client is equal to client list. List at index receive our client index dot sock. So then we'll get our client socket right there. Then let's see. Yeah, then we can do something like, so here's how we'll receive our message now, guys. So we'll first receive the length of our message from our client, right? And then we will allocate a buffer of that message length, and then we will receive our actual message or data from our client. Then it will work the same way for our client as well. So let's do that. So we'll do something like, we'll define a size t, let's call it message size right here, and we'll say, let's see, chatsock underscore receive, and we'll pass in our client, and we'll pass in our buffer, which will be a pointer to our message size, and the size of it will be the size of a size t. So that way we'll get our message size from our client that we need to allocate so we can receive our full data. Then we can say allocate some memory now on the heap. So we'll say char pointer message is equal to color message size of a char. Then we can say chatsock receive all. So now we'll utilize our function that will allow us to receive up to the maximum number of bytes we specify, which will be our full message. So then we can pass in our message buffer. Then we can pass in our message size. Oh, also we need to add 1 to our message size when allocating it, because we want to ensure that it is null terminated. That way if we read from our pointer, we don't read past the buffer, and we don't cause any seg faults. So we'll just do a return message right here. Now let's see. So we have this receive started flag, guys, and this receive finished flag. Now after we finish receiving a message, we'll want to do something like this. We'll want to say set our client list list at index receive arg client index dot receive finish equal to true. Now our start receive function, let's start working on that. So we'll essentially create a new thread. So let's do a pthread t new thread is equal to, so just new thread, then we'll do pthread underscore create ampersand new thread, and then our attributes will be null. Then we'll pass in a pointer to our chatsock list receive message function. Then we'll need to specify our argument, which will be a receive argument. So we'll need to allocate some memory up here for our receive arg t. So we'll say malloc size of chatsuck receive arg underscore t. Then we'll say we'll need to initialize our client index to be equal to our index, and we'll also need to do receive arg client list is equal to our sockets. Then we can just pass in our receive arg. Now, by the way, guys, the reason why we're allocating our receive argument on our heap is because we don't want to lose track of these pointers, right? Because if it was on the stack, as soon as we return from the start receive function, we would immediately destroy the stack pointer or stack frame. So we don't want that to happen. So once we do that, we'll need to do something like we'll need to initialize or receive started flag and set it equal to true. So we'll do let's see, we'll do receive arg. No, we'll do sockets list index dot receive started is equal to true. Then let's see, we need to also ensure we initialize our receive thread. So let's ensure we do sockets list index dot receive thread is equal to our new thread that we created. And then now, guys, we can start working on our join receive function that will allow us to get our actual message. Oh, and also, guys, since we're allocating this receive arg on the heap, we have to free it inside of our receive message function. So we'll, at the end of here, we'll just do a free receive arg right there. And that is it. All right. So our join receive will allow us to get our actual message. So we'll do a char pointer, let's say message right here. And we'll say, let's see, so we'll do a pthread join ampersand, no, we'll do a pthread join sockets list index dot receive thread, no, and then we'll pass in a reference to our message casted to a void pointer. Then we'll just return our message. Now we need to reset our receive started and our receive finished flag. So we'll say sockets list index dot receive started is equal to false. Sockets list index dot receive finished is equal to false. And that should be our receive. So now that we have done that, guys, let's see if everything is right. So we have a to-do right here. So after we accept our client, we need to ensure that we start a receive thread so we can receive a message. So we'll use our chatsuck start receive function. So we'll do something like chatsuck list underscore receive underscore start receive, and then we'll pass in our client list, and then the last index. So we'll do client underscore list count, and then that will start our receive thread for our client that we accepted. Right, so now guys, let's actually test it out. So this is our receive thread. We can get rid of all of this right here. Can get rid of this. Yeah, let's actually get rid of this old receive message function, and let's comment out this broadcast function, broadcast message function thing. Wait, let's do something. Hold on. Your chat server. You'll just comment this out. Yeah, so first thing we need to do is to create our exception thread, right? So let's do that. So we'll do a pthread t exception thread is equal to chatsock underscore list start accept, and then we'll pass in the exception argument. We'll need to define it above here, so we'll have a chatsock accept arg t exception arg, and then we'll do a dot client list is equal to a reference to our client list. Then we'll say our socket is equal to our server socket, and then we'll pass this in as a pointer to our exception or structure. And then at the end of this while infinite loop, we can just say chatsock list underscore join accept. Let's make it a underscore, and then we can pass in the exception thread. Let's rename this. Alright, so now guys, we'll start iterating through our client list. So we'll say for size t I equals 0, I is less than our client list dot count I plus plus. We'll then say we'll say if our client list dot list at index I dot receive started and client list dot list index I dot receive finished, then we'll do a chatsock list underscore join accept, join receive, then we'll pass in our client list, then our current index. Oh, this should be a reference to our client list, so a pointer to it. And then we'll need to store our message that we received, so we'll do a sharp pointer message. And let's just do a simple printf modulus s. message received from client was, and then we'll print out our message. Okay, from client. Let's actually print out the client number. So we'll just print out the index and then our message. So now guys, let's actually test out our application. So before we do that, we need to modify the way we send a message to our server. So if we go right here where we press enter, we'll need to first send the size of our message and then the actual message. So let's define a size T up here. Let's call it message size. We'll set it equal to the string length of our up input box.data. Then we'll do a check sock send up server socket. Then we'll pass our message size as our buffer or a reference to it. We'll then pass in the size of it, which is a size T. And then we'll send our actual message. We can replace the string length right here with our message size. And that should be it. Yeah, that should be it. So now, guys, let's actually test it out. So let's do a start cmd.exe. Let's make this full screen. And let's go into our check server directory. And let's try to build our server. Let's see if we get any compilation errors. Oh yes, we got one. Oh, implicit declaration of function printf at line 29. And okay, so we need to include our stdio within our chat sock list. So let's go to the top here. We'll do a hash include stdio.h. Let's go back and try to recompile our code. Okay, it's building. Alright, so our server built successfully. Now let's try to open up some split views. Pressing Alt-Shift-D, okay. We'll navigate to our desktop / chat up. cd into desktop / chat up. And let's try to build our actual chat application. Right, it's building. Right, it built successfully. Now let's write something in here to label it. Let's call this client 0. And let's rerun another one. Okay. So let's make this client 1. And let's press enter on client 0. It didn't get anything. Client 1. Well, for some reason, it doesn't get anything. Why is that? Why is that? Alright, let's try to debug this by printing out let's do a printf modulus s received message buffer, and we'll do our actual message. Let's recompile our server. So let's run client. Oh, here's our, oh, we need to, I see. So guys, it mistakes a connection for something else. So let's do a chat sock receive right here. We'll say if it is less than or equal to 0, then we will just return null. Let's not do that for now. Let's not do that for now. Oh, I realize what's going on. So we join our thread, right? Get the message buffer. And then join or receive. This is our message. We'll need to ensure that we restart our thread after we join it. So we'll do a chat sock list start receive in our client list right here, and then our index. Okay. Okay, let's see if we're doing everything right. Oh, shoot. This is what's causing the issue. So it should be our last index right here. It should be our client list count -1. So if we, let's just close this application and then recompile our code for our server. All right, so let's wait on that to compile. So it's building. All right, now let's execute our main. And let's execute. Oh, let's label it first. Let's make this be client 0, and then let's do another main. And let's make this be client 1. And yeah, let's try something. So let's try to press enter. Alright, so we received our message from client 0, nice. Press enter. Okay, cool. So if we do, let me see some. So if I create another connection, alright, it received that connection. Okay, so let's make this be client 2. Alright, so it works. So now guys, let's actually make it so we send the message over from our server that we receive. So that's just gonna be relaying our message. So it's pretty straightforward to do this. So let's do it by, we don't even need a broadcast thread, to be honest, for now. Yeah, we'll keep it simple for now. So we'll have a void broadcast message function, and let's say it will accept our server, it will accept a client socket, so it will be a chat sock t. Let's say socket, so that will be the socket that it will ignore, and then it will have a chat sock list t pointer client list. So we can get rid of all of this right here. We can iterate through our client list. Wait, let's not pass in a socket there. Let's instead pass in a size t index, and we'll also pass in the message that we want to broadcast or relay to the other clients connected to the server. So we'll have a chat sock t right here. Let's call it client. Then we'll say it will be equal to our client list index dot sock. Then we'll do client list index I dot sock dot fd. So if it is if that file descriptor is equal to our current file descriptor, right? So we're essentially checking to see if the sender of the message is not equal to the receiver of the message, because we're gonna be sending it to other clients on the server, right? So as long as it's not equal to the sender, then we will send the actual message. So we'll do a chat sock send dot sock right here, and then we'll put in our message, and then we'll need to get the size of our message. So let's just put it in here, but let's just copy this and let's move it up here. We'll have a size t, let's call it message size, make it equal to the string length of our message. Then we'll get our message size right here. Now remember guys, we changed the way that we're sending our message, right? So we need to first send our message size from our server. So we'll do chat sock send client list at index I dot socket. Then we'll pass in a pointer to our message size. Then it will be equal, then the size of our message size, which is, it will be the size of a size t. So then, after that, we will utilize our broadcast function. So once we receive a message, we will broadcast it. So let's do a simple login thing right here. We'll say broadcasting message to other clients, broadcasting / relaying message to other clients, and then we'll actually call our broadcast message function. Then we will pass in a pointer to our client list. Then we will pass in our index, which will be I. Then we will pass in our message, which will be our message. Oh, and also, guys, this message is heap allocated. So we cannot forget to free our message, by the way. We cannot forget to do that. And yeah, this looks good now, guys. So let's actually try to run or build our server. Oh, and also, guys, we can't forget to modify this receive so that it works the same way as our server, right? So we'll first need to have a size t up here. Let's call it server message length, and we'll set it equal to 0 for now. We'll then do a check sock receive up server socket, and then we'll pass in a pointer to our server message length. Then we will pass in the size of a size t for our buffer size. So then we'll get to our message size. Then we can allocate a buffer on the heap of that message length plus 1. So we have the null character terminator included. Then we can do a chat sock receive all. So we get our full message, and then we pass in our server message length. So now we can then just return our server message, and yeah, I think this, yeah, everything looks good. Okay, so let's test out our actual application. So let's build it, guys. Right. Hopefully it works. Alright, so now we have this window. Alright, let's try to label it. So this is client 0. Let's send a message like, hey client 0 dash hey, and then we'll execute another window. We'll label this one as client 1 saying hey, and then let's execute another one. We'll label this one as client 1 saying hey, and let's populate, hold on, let me just move these around and try to send message. So we can press enter. Alright, and it works. It works, guys. Look at that. Yeah, each of our client receives our message. Let's try to send one from client 1. Yup, all of them receives it. Alright, let's try to send it from client. Oh, this is supposed to be client 2. So if we press enter, alright, so it works, guys. So anyways, guys, this will be it for today's video. In the next video, we will start handling client disconnections from our server, right? So that way when we close our application, our server will close the client gracefully, you know. So thank you guys for watching. Alright, thank you guys for watching. Don't forget to hit the like and subscribe button. So I'll see you guys in the next episode.